Okay. Hello, here's 5-9. There's a lot to cover here, so you might want to make sure you understand everything that's going on here. You may need to pause and look at it later, that type of thing, as you're working through some problems. This one is dealing with operations with complex numbers, and the first thing we want to be able to do is we want to look at graphing with complex numbers. Now, when you're graphing, you need to keep in mind that what you're trying to do, think of instead of like an x and a y, we're going to have a real and imaginary axis. And keep in mind, when we look at a complex number, we say a plus bi. Okay. So the real part is the a, and the imaginary part is the b. And so we're like graphing. We're thinking that as the a is almost like your x, and the b is almost like your y. So for example, you can see here, I'm going to graph 3 plus 0i. Okay, so I went 3 spots. I'm sorry, that's actually -3 plus 0i. So I went 3 spots to the left because the -3 is the real part. It's like the x. And we're thinking of the 0 as the y, and I don't go up or down any. So keep in mind, the a part goes left and right, the b part goes up and down. Okay. The next one is -3i, which you can see here. There's no real part. That means there was no x. So, or there was no a, little a. So there, since I didn't go sideways any, I just have an I part that has me go down 3. Okay, and then the next one for C, let's say 4 plus 3i. Okay, so that would tell me to go 4 to the right and then 3 up. So I'm going 4 to the right and 3 up, and there's my letter C. For D, or for point D, I'm going to say -2 plus 4i. That's telling me go 2 to the left and then 4 up. So I do that, and there's my letter D. Let's do a letter E. 5 minus I. That would tell me go 5 to the right and 1 down. And there's letter E. So that's graphing complex numbers. It's not very hard. You can kind of see that. Now, keep in mind that the origin is in the middle, as always, and we can do what is called the absolute values of a complex number. And the way to do that, the definition of that is this. The definition of the absolute value of a complex number says that this is measured is a squared, is the square root of a squared plus b squared. Notice I ignore the I. Because what you're doing is you're measuring the distance from the origin to that point. So like in this example right here, I could say 3 squared plus 4 squared is 25. The square root of 25 is 5. So the absolute value of 3 plus 4i would have been 5. Okay. Let's go through some other examples on that. You can kind of see like how we're trying to look at this and think of like Pythagorean theorem. This is how they kind of came up with it. But let's look at some other examples here. -9 plus I. So I would say -9, or I would say -9 squared, keeping that in parentheses, and there's a 1 presumed in front of the I if I don't see a number, and I'm going to say 1 squared. Well, 9 squared plus 1 squared is 81 plus 1, which would be 82, square root of 82. And there's nothing else I can do with that. Okay, let's look at another one. The absolute value of 6. Sorry, I kind of didn't see that for a second. The absolute value of 6 is 6. We think of that as 6 plus 0i, so I would say 6 squared plus 0 squared. And that would give me 36, which would just be 6. Okay, and if you can get the square root, get the square root. Let's look at the absolute value of -4i. The absolute value of -4i is like saying 0 plus 4i. -4i. Sorry. And so I'm going to say 0 squared plus 4 squared, -4 squared. Notice how I'm putting the -4 in parentheses, and that would be square root of 16, which is just 4. Okay. One more example, 1 minus 2i, which would be 1 squared plus -2 squared. Again, notice how I'm putting that in parentheses, which would be 5. There's nothing else I can do with that, so I'm done. Adding and subtracting, I don't think this would be too hard. It's just like combining like terms. There's really nothing else I can do to make this hard. All you're going to do is try to make sure that you line up everything correctly. So for me, what I like to do take this problem, negative 2 plus 4i, 3 minus 11i. I like to line them up like the way you're seeing there. So notice how I put the 3 under the 2, because that's the real parts, and the i's are lined up. So I'm going to say negative 2 plus 3, which is just 1, and 4 minus 11, which is negative 7. And I'll put the I with that. And I'm done. That's it. Now, when I do something like subtraction, 4 minus I minus 5 plus 8i, okay, I am going to make sure I distribute the minus to both numbers. So when I rewrite it under, because I like to write them under, 4 minus 5 and negative I minus 8i. So then I'm going to say 4 minus 5 is negative 1, and negative 1 minus 8 is negative 9i. Okay, that's all you really need for adding and subtraction. It doesn't get much harder than that. Let me do one more example, or some more examples here. 10i, you can see how I've redone this. Okay, so I have 10i plus 3i minus 10 minus 4i. Notice that I distributed the minus, that became a positive 10 or negative 10, but the minus 4 became positive. So 10 minus 10 is 0, and 3 plus 4 is 7i, and you can write it as 0 plus 7i, or you could write it as just 7i. So I think this is the last example right here. We got negative 3 plus 5i plus a negative 6i, so I could rewrite it like that and say negative 3 plus nothing is still negative 3. 5 minus 6 is negative 1. And so I could put minus 1i. That should be pretty easy, and those are problems that you should do really well with on the test. So think about it like that. There's a lot of easy problems where you can get a lot of freebie points here. Alright, now let's get to multiplying. This is when we started having to be a little bit more careful. Okay, multiplying complex numbers. The key to this is you've got to remember that I squared is equal to negative 1. Okay, so keep that in mind. And the reason why is because I'm saying the square, when I say like the square root of negative 1 squared, the square and the square would cancel each other out, leaving you negative 1. Okay, so you can see here I've done a problem, and it said 2i times 3 minus 5i. Well, I did 2i times 3, which is 6i. Then I did 2i times 5i, which is negative 10i squared. Now, since the I squared is negative 1, I'm going to say negative 1 times negative 10, which would become positive 10. And I would rewrite it so that it's real, then imaginary. Okay, so let's look at another example. 5 minus 6i, and then I'm going to have another parentheses, 4 minus 3i. Now, you may see this and you may think that like you can do FOIL, which would be multiply first, outer, inner, last, distributed property, whichever. I like to do what I call an old school method, which is like vertical multiplication, kind of like what you used to do for 2-digit multiplication back in elementary school. So I rewrite it like this, and I'm going to say, okay, well, let's do negative 6i times negative 3i. Negative 6 times negative 3 is 18, positive 18. I times I is I squared. Okay. Then I would do negative 6i times 4. Well, negative 6 times 4 is negative 24i. Then I'm going to go to 5 times 3, kind of like what we would do in 2-digit multiplication. But here I don't have to worry about carrying anything over. And so I'm going to say 5 times a negative 3 is negative 15i, and 5 times 4 is 20. Okay. And see, when you do it like this, everything's all lined up. I can say here, negative 24 minus 15 is negative 39i. Or negative 39i. You've got to remember the I squared is negative 1, so a negative 1 plus the 18, which all that does is change the sign. Every time you see an I squared, you'll drop it and change the sign of that number. So you got minus 18, and I've got a 20. 20 minus 18 is 2. So my final answer should be 2 minus 39i. Practice with those, and that should get pretty easy. One more example here. I want to do 7 plus 2i and then 7 minus 2i. And you can see here, notice what happens. The i's will cancel out because those are difference of, they're basically the same thing, but one's adding, one's subtracting. And when we do this, we end up with just a regular number, 53. Also notice, like if I did 6i times 6i squared, or 6i times 6i, that would give me negative 36. So kind of keep those like special shortcuts in mind. Always remember, with the I squared, that will become -1, which changes the sign of the number. Alright, so now let's look at powers of I, because this becomes a pretty important idea. Notice what I'm going to write here. I'm going to say I to the first is 1, or I, which we know. I squared is -1, which we, again, already know. Now, I cubed is like saying I squared times I, which means -1 times an I, which means it's just -I. And I to the fourth power is like saying I squared times I squared, which would be -1 times -1, which is 1. I to the fifth is just I to the fourth times I, which would be 1 times I, which is I to the sixth. And I'm trying to show you this so that you can hopefully see a pattern. I squared to the fourth times I squared, which we now know is 1 times -1, so it'd be -1. And I to the seventh is I to the fourth times I cubed, which would be -I. I to the eighth is like saying I to the fourth times I to the fourth, which would be 1 times 1, so it'd be 1. The pattern repeats every 4. So, what can we do with simplifying powers of i's? Because if it starts repeating, that means I can just, always make it simpler. What we can do is divide the exponents by 4. And look at the remainder. You always will divide by 4. So if I say like I to the 25th, simplify it. Divide the 25 by 4, and I have a remainder of 1. That's what I care about. I don't care about that 6. I have a remainder of 1. And according to our chart, when it's I1, it's just I. Okay, so here the answer is just I. You only look at the remainder. If it's a 1, you say I. If it's a 2, you say -1. If it's a 3, you say it's if it's a 3, you say it's -I. And if the remainder is 0, then you just put 1, because that represents I to the fourth. Okay. Again, see here, I had a remainder of 2 when I divided 42 by 4. That's I squared, which means it's -1. Alright, so now we get to the last part, dividing complex numbers. Okay, and I'm trying to explain this in the simplest terms as possible. The idea here is we're trying to rationalize the fraction. And the way we do that is we're basically trying to get rid of the I in the denominator. And the way to do that is to multiply by the conjugate. Okay, so that's going to be our key thing here. And I'm going to have several problems that go over this. But we're multiplying by the conjugate. And so let's do an example here. 3 plus 7i divided by 8i. Okay, I need to multiply by the conjugate, which would be min. Remember, the conjugate is changing the sign of whatever is the I. Okay, so the positive 8i becomes negative 8i. Notice I'm multiplying top and bottom to that. Okay, so I'm trying to show every step here. I'm going to distribute property, so I'm going to do 8 times 3 is negative 24. I'm going to do negative 8 times 7 to get negative 56. And I times I is I squared. 8 times 8 would give me negative 64. 8 times negative 8, and I times I is I squared. Okay. Now remember, the I squared means they become positive numbers, or they change signs. So I have 56 minus 24i over 64. Because that negative becomes positive now. If I simplify those, all three of those numbers are divisible by 8. And if I simplify it, I would get 7/8 minus 3/8. So I rewrote them as two separate fractions, I. You could write it as 7 minus 3i over 8. I don't mind, but this is like the supposedly proper way. Okay, so here's another example. 5 plus I over 2 minus 4i. Again, notice here I'm multiplying by the conjugate. 2 plus 4i. Okay, so took the 2 minus 5i and changed the sign. Well, now I'm going to multiply. And pay attention here. There's a pattern if you look at this pretty soon. I'm multiplying the denominators. I said, oops. Okay, I kind of just messed up there, so give me a second. Okay, so I think I'm back to where I was. Okay, so I said 2 times 2 is 4. 2 times a positive 4i is 8i. 2 times a negative 4i is negative 8i. And 4 times 4, negative 4 times 4 is negative 16. I times I is I squared. Okay. Then I'm going to do the same thing on top. I'm going to distribute. 5 times 2 is 10. 5 times 4 is 20i. I times 2 is 2i. And then I times 4i is 4i squared. Okay, if you notice here, the 8 i's will cancel out. And I've got 4, and then I've got I squared, negative 16i squared. That becomes positive 16. 4 plus 16 will give me 20. Okay, so I just wrote the 4 plus 16 for now. I've got here 10. The 4i squared will become minus 4. And I can combine the i's. 20 plus 2 is 22i. Now combine my like terms. I end up with 6 over 20. Or 6 plus 22i over 20, because 10 minus 4 was 6, 4 plus 16 was 20. And then when I divide, or when I simplify, I end up with 3 over, because every number is divisible by 2, 3 over 10 and 11 over 10i. Okay. And that's how you would pretty much solve those. Okay, there's going to be one more example that I'll go over, and then we'll be done, and you'll hopefully be able to understand what you need to do for the assignment. Okay, so for another example, let's do 8 plus 2i over 5 plus i. Okay, so that means we need to multiply by the conjugate, which would be 5 minus i, top and bottom. Now, if you didn't notice the pattern before, here's the pattern. For the bottom, all you got to do is take the 5 times 5, or 5 squared, which is 25. Okay, take 1 times 1. Ignore the sign. It will always be plus. 1 times 1, which is the number in front of the I, is 1. 25 plus 1 is 26. There's your denominator. Every time, because if you do this right, there will never be an I. So you're just saying 5 squared plus 1 squared. And then I can do 5 times a, which is 40. 5 times, or 8 times negative I, which is negative 8i, 5 times 2, which is 10i, and 2 times negative I, which is negative 2i squared. So I would have 40, remember that minus 2i squared will become plus 2, so 40 plus 2 is 42. 10 minus 8 is 2i over 26. Simplify, you got 21 over 13 plus 1 over 13i. And that's your answer. That's dividing. That's 5-9 in a nutshell. If you have any questions, make sure to ask. Otherwise, you should be working on this assignment, and hopefully this will give you an easy understanding of some problems that should be easy for the test.